We're going to open this VLC that we just downloaded, this completely legitimate VLC, but just keep an eye on the bottom right when we open it. Wait, I can try and be more surprised. That's better. So what does this mean? In order to screen share, we can actually stream that user screen. How sick is that? Check 1, 2, 3. Hello. Today we're going to do three things. We're going to check to see if a file is malicious, how we can do that, what a malicious file can actually do, and how we can turn a legitimate app or program into a malicious one. Let's go. Here we have two files, both alike in dignity in Fair Verona, where we lay our sick. I'm getting carried away. Like I said, we have two files. Both look exactly the same and function exactly the same on the surface, but down in the depths of the ocean of the sea. Yeah, I'm getting carried away again. Things are different down below. So how can we check if a file is malicious? Instead of just relying on AVs to catch it. We're going to start here with the coolest method first and then gradually move towards the more boring but necessary things like checksums. We're going to open both of these files in something called DIE, or Detected Easy. We're going to open two of them, so we're going to open both files. We'll add the one, we'll add the other one. And then we're going to go to Advanced and Entropy. And what we're going to check here is we're going to check the entropy of one of these sections. I don't know if I mentioned it before, but both of these VLC files were legitimately downloaded, but one of them was just injected with malicious code afterwards. So these sections is basically like a map. It'll tell when the machine loads the exe, it'll tell it how to run, when to run stuff. And we are specifically looking at this one here called GNU debug link. And yes, it's called GNU, and not to be mistaken for the animal, because they prefer to be called Velibius, not a new, or whatever they call it. So as we can see here, the sections they're all pretty much the same, apart from this one, GNU debug link, that stands out. So GNU debug link doesn't usually appear in Windows PE files. It's more common in Linux ELF binaries. But if your exe was compiled or processed with GNU tools, it might embed this section. But this section just stores a reference to an external debug info file. But that's just some extra info. So why is this important for us? So why are we going to look at the entropy of a file? What is the entropy? The entropy is a measurement of randomness. And a higher entropy means that the file has likely been packed or encrypted or contains some obfuscated data. What's a packer? If I say packed, a packer is something that it takes your program and transforms it into like a smaller, more obfuscated form by encrypting the contents of the file. Yeah, and this is largely used by it's used by legitimate people, but it's also largely used by malicious actors because it makes it more difficult to then reverse engineer that exe. Okay, finally got those words out. As we can see here, 6.5 compared to 0.3. 6.5 is high, but not too suspicious by itself. But if we look at the other file, this file is obviously significantly less. So, suspicious much? So when we look at these two, we can already, just by looking at the entropy of this section, we can already start to think which one could be the potentially malicious file. Okay, so that's one way. So the other thing we can do is we're going to open something called ProcMon, or Process Monitor. ProcMon shows you all the system level actions that a program makes, like what files it opens or modifies, what registry keys it reads and changes, and what other processes it creates or interacts with. So here we can just see all the different processes that's running, and we can see their operations, we can see what PID they run in. But what's quite useful for us is looking at the operation, like what it actually does. Okay, and then we can also look at the details here. But what we're going to do is we're going to run those two VLC files, and we're going to look at the output in here. So first what we're going to do is in ProcMon, because this is a lot of information that's getting put out here, this is all the processes running and we don't want to see all the processes. So we're going to put in a filter. So first we're going to do process name is, and we're going to type in VLC because that's our program, and we're going to add that. And then we're just going to press apply and OK. As we can see here, no VLC is running just yet. So let's pick this one. Obviously I'm picking this for a reason. So if we run this one, it runs perfectly. I will run this bad ego VOD of me playing Overwatch. Okay, let's just cancel that. As we can see, running it works perfectly. And a lot of this is legitimate processes, as the program's actually legitimate. But if we come down to the bottom, we can see here some TCP connections. It's trying to connect. So this PC is trying to connect on this port to this random IP on this port. Now, VLC, for those who don't know, but I'm sure everyone's familiar with VLC, is a media player. So you play videos with it. If you see any TCP connections, so TCP is basically if one computer is talking to another computer. So you think about opening VLC, your computer should not be trying to talk to another computer. It should all be contained within your own machine, right? So when you see that, when we see TCP connections to a random IP, that is very suspicious. So here we can already establish that this one is the malicious file. What we can also do is we can open Task Manager, and we can go to Performance there, and then Resource Monitor. And in here, we can look at TCP connections as well. So if we run, because it didn't make a connection, it didn't keep it open. But here we can see that we can see this TCP connection in here as well. So that's another way of looking at connections. And this is something that anyone can just do because everyone has got Task Manager on their Windows machine. Another way we can have a look at this, if we just close all this so it looks nicer. If we close all this, we run VLC again. If we just open terminal and we do netstat-ano, what we can see here is we can see the same thing. We can see a TCP connection from our machine, which is .132, which is this machine, and we can see it's trying to contact something on the outside, a foreign address on port 8001. And that is suspicious in itself. Okay. Sometimes, yes, your machine is going to contact foreign addresses because it's going to, it always does, because that's the internet. But when you see when you go through it and you see one that stands out on a random port, that's when you should be suspicious. So let's switch over to our Kali machine now. And what we're going to do is we're going to look at the hexdump of the two files. So if we do Objdump, and we're just going to include this section of GNU debug link, and we're going to pass in the file. So if we look at this one first, because this one is the legitimate file, and we do vlc.exe, what we can see here is if we look at the first line, we can see that it's outputting vlc.exe.debug. Okay, that's the name of the debug file, and then it's just followed by the crc checksum. So okay, that's all the info that's in there. All of the rest of this could just be zeros, so there could be nothing else in there. Okay, so if we look now at the malicious one, if we go to the top, we can see here that this first line is the same, okay, and then we can see all of these zeros in here, which is fine, which is the same. It's just not showing in here because it is all zeros, so there's no point in displaying it. But these are all zeros, and then all of this that looks like garbage, okay, is in here. And as we can see, that's a big difference going from this one that's got pretty much nothing in here compared to this one, right? So how is this possible? How can we actually do this? So what we utilized here is a code cave. And a code cave is like a secret hideout. It's unused space. A code cave is unused space in an executable where we can inject extra code without overwriting the original program's execution. So like we saw there with all those zeros, if there's loads of zeros, we can maybe take some of those zeros out, put our own code in there, but do something special so it goes to our code and then jump to the original code again. So the flow is still perfect. So how the original flow would work, the program would start, it'll go from instruction A to instruction B to instruction C. But what happens here is the program starts, it goes from instruction A, and then there's a jump instruction to go to our malicious code, which the malicious code executes. It then has another jump to instruction B, and then instruction C, and so on and so forth. So it's still executed in the right line, but it just went to ours, like a little shortcut. Maybe shortcut isn't the right word. It went to ours in between, just a little detour, and then it went, but it goes so quick that they both basically go simultaneously. So A to malicious code to B to C, and so on. So we can refer to these zeros as gaps. And what we're going to do is we're going to use a program called Shellter, which is going to find these gaps for us automatically and insert malicious code into these gaps without altering the original program's execution. But we'll talk more about that in a minute. Yeah. First, we need to talk about the boring stuff quickly, and that is boring but necessary. Boring but necessary. We're going to talk about checksum comparisons. So when you've got two files that look exactly the same, if just one minor thing has been changed on this file, like one byte has changed, their hashes are going to be completely different. And a hash is basically a long string. If you think about a long piece of text that's got numbers and letters in it, and they should both be exactly the same, but if one thing is changed on this one will be completely different. So it's just two words basically, and the word will be different. So here we have the official VLC website. If we go to download this zip package, which is a standalone package, which is the one we're using, if we go, we're downloading it now, but we can also go click on that checksum, and then here we see it's SHA-256 checksum, and we see this. Okay, I know it's quite small. Right, let's zoom in. So we can see this, okay? So we can see this. What we're going to do is if we copy that, so back on our Kali machine, we can see that we've got these two zip files. This is the one that we downloaded from the website, and this is the malicious one. And they're in zip files because it's standalone VLC players. So what we're going to do is we're going to use that hash that we just copied. So if we chuck this in here, we're putting, that's the hash that we copied, and we're going to compare it to this VLC, the legitimate one that we downloaded, and we're going to use SHA-256 and -c for compare. So if we run that, we can see that, okay, they're both the same. The hash on that and the hash on that is both the same. If we now change this, if we change the file to vlc.zip and we run that, we can see here, failed, one checksum did not match. So we can see there that something has definitely changed within this vlc.zip, and from that we can definitely ascertain that that is not the original file. We can also run this on Windows with get file hash, TAC algorithm, SHA-256 and the file name, and then you can get it that way as well, but let's not get to Windows. Okay, now for the part that you've been obviously waiting for. What can this malicious file actually do? First, we're going to set up a listener. So what this does is it opens MSF console, which is like a Swiss Army knife for hackers, basically. That's the best way to describe it. So what we're doing is we're opening MSF console. We're going to use this multi-handler, which is the listener, and we're going to set a payload, which is the same payload that we've got on the actual VLC. Reverse TCP, so they connect back to us. And here we've set our listening host, our listening port, and we've set exit on session as false, just because if the session closes or if they disconnect, we don't want to close the session, we want to keep it open, so in case they connect back again. Okay, we're going to run that. So with Metasploit started, we're going to come here and open VLC. And as we can see in that bottom corner, we can see that Meterpreter session 1 has been opened. So if we now go into that session, we can see that we are in fact on PAM-PC user. But what happens if this VLC player, because if they close this VLC player, if they close it, we can see that Meterpreter session 1 has been closed, so it died. So we can't, if we now check sessions, which sessions is basically a way into, if we've got a connection, like that TCP connection back into someone else's computer, that's what the sessions are. So if we've got no active sessions because they've closed VLC, so what can we do with that? Okay, let's say we run this again. So this is our listener listening for any connections back to our machine. If we now run, if the victim now runs VLC again, what we can see here then, so they're running VLC. If we now do PS to look at all the processes, we are running in, wait for it. Oh, my eye's just deceiving me. Stands out right there. We're running in PID 1144. So every time VLC gets closed, our session gets cancelled or gets killed. So what we can do is if we change to another process, so let's say we pick OneDrive. So we're gonna now migrate to a different process. So we're gonna move out of our process and move laterally to this. So okay, so we're gonna do migrate, what was that, 3512. So we're gonna migrate from our VLC process into a different process. So now, even if VLC was to be closed as it is now, we can still, on here, we're still active on that machine. So that's pretty cool, right? So Meterpreter has got a couple of inbuilt functions. If we do help, we can see here, there's a whole list of things we can do with Meterpreter. One of the things we can do is we can just get a normal shell. So we're on the user's machine now. So we can just do normal commands. As we would. But we can also cancel that, and Meterpreter's got built-in functions. So one of them is if we do screenshot, I can see here that it actually took a screenshot of that user's machine. Now this can be scripted, so it keeps taking shortcuts, screenshots all the time. We can also do something called screen share, and that will actually share as a live image of the target machine. It can keylog as well. So if we do key scan start, it's going to start a keylogger on the target machine. So let's say they open Notepad and they just type. What we can now do in Meterpreter is if we do key scan dump, we can see here it logs all the keys and all the words that was typed. So it doesn't matter where it's typed, it's going to log it. So why should we care about the key logging? Well, if they have a live image of your screen and you're typing passwords in, they might not be able to see the password on the live image, but if they've got key logging enabled as well, they can put 2 and 2 together and see the sites that you log into, but also have the password. You get me? Okay, now let's move on to the even cooler bit, I would say, is just how. Like, how is a legitimate file getting made into a malicious file? Because as we can see, that VLC was running the same as the other one, but also we got a reverse shell back to our attacker machine. So like we mentioned previously, we're going to use a program called Shellter. And Shellter is a dynamic shellcode injection tool. It can be run on Linux distros as well as Windows. The thing that makes Shellter so cool is Shellter doesn't create new sections, it just expands already existing sections, which makes it more stealthy. And so it also maintains the program's original execution flow, so it just runs as normal. And it also uses the program's import addressing table, so it avoids loading any suspicious DLLs, which just makes it more stealthy. Okay, now let's talk about how we can use and install Shellter as well. So the first thing we got to do is we got to add architecture for 32-bit. So this command adds support for 32-bit architectures on a 64-bit system like Kali Linux. So first we're going to do that. I've already done it, so I'm not going to do that again. Then when we've added support for new architecture, we got to run sudo apt update. And after we've run that, we can install. So we need to install Wine and Shellter. So Wine lets us run Windows programs on Linux. So we got to install Wine, and then we install Shellter as well. We can also do this on Windows. So for Windows users, you can go to the official Shellter site or the GitHub repository. So if we now run Shellter, we can see that's running through wine, and it'll take a second or two or three. I can do with wine just waiting for this. Okay, we're in. So first we're going to choose our mode of operation, which we're going to go for auto. Then our portable executable target. So this is the location of that exe file. So if we just have a look, so it's going to be in that VLC folder. Sorry, it's going to be in the original VLC folder. So if we type in that, then /vlc.exe. So that's going to be our portable executable target. Run that. What it's doing now, it's creating a new directory there with the original file in it. So we'll get back to that in a second, because that's important to know. So it's going to do its little bit now. As soon as it finds a suitable place for us to inject our payload, it's going to ask us if we want to enable stealth mode. And stealth mode is, it will attempt to restore the execution flow of the portable executable after our payload has finished running or been executed. That's a better word, executed. This allows the exe to behave normally, so to avoid any suspicion, because we don't want to be suspicious. So here it says enable stealth mode. Yes, we want to enable stealth mode because we want that to run as normal. Now it's asking us if we want to use a listed payload as here, or if we want to use our own custom one, which is pretty cool. But we're just going to use a listed one, like the one we used in the previous example. So L for listed, and then we select the payload. So we can select one for a Meterpreter reverse TCP. So click one. Now we're going to set the listening host, which is our IP here, which is 192.168.44.129. Obviously yours is going to be different. Then we're going to set the listening port. You can set that to whatever you want. Normally you want to keep it something that's not going to be suspicious. Just for this, I've just put it to something that stands out a bit, because just to make it more obvious. But you can set it to 80 or 443. So you run that, it's going to do its thing again. It's going to be pretty quick now. And then it's going to ask us to press enter, but it's going to continue either way. So we'll listen to it and press enter. Now if we have a look, we can, let's just remove all of this stuff. What was that, HTML? Let's just remove that. So if we have a look here, we can see that it created this directory, Shellter backups. And if we have a look in that, we can see VLC. So this one that is put in here is the original file. So it's already injected the malicious file into this directory that we gave it. So that's just something to be aware of. If you're gonna then copy this file into that folder, then it's just gonna run as normal. So you're not gonna have a malicious file. That's just something to be aware of. And that's as easy as that. That's how we create a malicious file from a completely legitimate file that we just downloaded. I will put links to all of these programs down in the description. I don't know why I did that. I should have done that. Okay, let's just quickly talk about the important part now, like how can you protect yourself? So firstly, don't download from unofficial sources, especially if a site looks dodgy, just don't download from it. But if you do, if you can find the original checksum hash, like we did on one of those steps, always make sure that that checksum that hash is the same as the hash of the one that you've downloaded. Because if they don't marry up, something's obviously changed. Also, if you're going to run, so all of this was run in a sandboxed environment, and what that means is it's a virtual machine. So this Windows machine was a virtual machine that's cut off from the internet. So if you're going to download a file and you want to run these checks on it, like checking what processes it calls, analyzing the file, even if you're just going to open it in DIE, just run it in a sandboxed environment that's cut off from the internet, just in case it is trying to call out to something. So analyzing the file is important, but do it from a sandbox environment. And then also get an antivirus that's behavioral based, it doesn't just look at signatures. So it's actually a smarter antivirus. And yeah, those are the tips. Anything else? No? Okay. Oh yeah, thank you for watching.